Okay, find the y parameters of the network shown in figure. So this is the given network. So first the given network. Here 1 comma 1 dash terminals are called port 1, 2 comma 2 dash terminals are called port 2. Here V1 comma I1 port 1 voltage and port 1 current, V2 comma I2 port 2 voltage and port 2 current. So the y parameter formulas. So first y parameters are y11, y12, y21 and y22. y11 equals to I1 by V1 at V2 equals to 0. y21 equals to I2 by V1 at V2 equals to 0. y12 equals to I1 by V2 at V1 equals to 0. y22 equals to I2 by V2 at V1 equals to 0. So here to find y11 and y21 we have to set V2 equals to 0. So V2 is second port voltage. So second port voltage 0 means, so we have to short circuit port 2 to set V2 equals to 0. So similarly to find y12 and y22 we have to set V1 equals to 0. So V1 is port 1 voltage. So to set V1 equals to 0, so we should short circuit port 1. So by short circuiting port 2 we can find y11 and y21, and by short circuiting port 1 we can find y12 and y22. So first find y11 and y21. So to find y11 and y21, first set V2 equals to 0, it means second port should be short circuited. So this is the corresponding network. Here second port is short circuited. So V2 equals to 0. So V1 port 1 voltage, I1 port 1 current, I2 port 2 current, V2 port 2 voltage, it equals to 0. So find y11. So y11 equals to formula I1 by V1. So to find y11, express V1 in terms of I1. So V1 is port 1 voltage, I1 is port 1 current. So generally formula V equals to I into R. Here R equivalent is the resistance across the port 1 terminals. So V1 port 1 voltage, I1 port 1 current. So R equivalent means the equivalent resistance across the port 1 terminals. So here we have to find the resistance across the port 1 terminals. So reduce the network from opposite side. So first last two elements, one short circuit, next one 2 ohms. Here 2 ohms and short circuit in parallel connection. So equivalent resistance of this combination. So use formula R1R2 by R1 plus R2. So short circuit resistance value equals to 0. So 2 into 0 by 2 plus 0. So this combination equivalent resistance value equals to 0. So this circuit becomes, so replace this combination. So 2 ohms short circuit combination by 1 short circuit, like this. So next one here, last two resistances 4 ohms and 6 ohms. These two elements connection, parallel connection. So equivalent resistance value. So use formula R1R2 by R1 plus R2. So next this total combination in series with 1 ohm resistor. So finally R equivalent equals to 4 into 6 by 4 plus 6 plus 1. It equals to 34 by 10 ohms. So R equivalent equals to 34 by 10 ohms. V1 equals to I1 into R equivalent. V1 equals to I1 into R equivalent equals to 34 by 10. So it equals to 34 by 10 into I1. Y11 equals to formula I1 by V1. So I1 by 34 by 10 into I1. So it equals to 10 by 34, or it equals to 5 by 17 units are moles. Y11 value 5 by 17 moles. So next find y21. So same, consider this network. So by using this network we can find y21. y21 equals to formula I2 by V1. So express V1 function of I2. Express V1 function of I2. So here number of loops equals to 2. So first loop, second loop, first loop current is I1. Assume direction clockwise direction. So next second loop current is I2. So current direction anti-clockwise direction. So loop 1 equation. So apply mesh analysis at loop 1 equation. V1 minus 1 into I1 minus 6 into I1 plus I2 equals to 0. So equation becomes V1 equals to 7 into I1 plus 6 into I2. Equation 1. So next write loop 2 equation. Loop 2 equation minus 4 into I2 minus 6 into I2 plus I1 equals to 0. So equation minus 10 into I2 minus 6 into I1 equals to 0. So 6 into I1 equals to minus 10 into I2. I1 equals to minus 5 by 3 into I2. Equation 2. So next to substitute equation 2 in equation 1. Substitute equation 2 in equation 1, then equation 1 becomes v1 equals to, so 7 into minus 5 by 3 i2 plus 6 into i2, v1 equals to minus 35 by 3 i2 plus 6 into i2, it equals to minus 35 i2 plus 18 i2 by 3, and v1 equals to minus 17 by 3 into i2. So next y21 equals to formula i2 by v1, i2 by substitute v1 equals to minus 17 into i2 by 3. So finally y21 equals to minus 3 by 17 moles. So y21 equals to minus 3 by 17 moles. So next find y12 and y22. So to find y12 and y22, set v1 equals to 0. It means first port should be short circuited. So first port should be here short circuited. So v1 value equals to 0. I1 is port 1 current, v2 port 2 voltage, I2 port 2 current. So first find y12. y12 equals to formula I1 by v2. So to find y12, express v2 function of I1. So write loop equations. Here number of loops equals to 3. So first loop current I1, second loop current equals to I2 dash. Assume second loop direction clockwise direction. So next third loop current equals to I2. So third loop current direction anti-clockwise direction, first loop current direction clockwise direction. So first loop 1 equation. Minus 1 into I1 minus 6 into I1 minus I2 dash equals to 0. Here in 6 ohm resistor, I1 current flowing downward direction, I2 dash current flowing upward direction. So minus 6 into I1 minus I2 dash equals to 0. So equation minus 7 into I1 plus 6 into I2 dash equals to 0. This is equation number 1. So next loop 2 equation. So minus 6 into I2 dash minus I1 minus 4 into I2 dash minus 2 into I2 dash plus I2 equals to 0. So it equals to 6 into I1 minus 12 into I2 dash minus 2 into I2 equals to 0. Equation number 2. So next one loop 3 equation. V2 minus, so V2 here plus, here minus, current direction anti-clockwise direction. So minus 2 plus plus V2 plus 2 minus minus 2 into I2 plus I2 dash equals to 0. So V2 equals to 2 into I2 plus 2 into I2 dash. Equation number 3. So next by using these three equations, so we can write V2 function of I1. So by using that relation we can find y12. So next one, so from equation 1 write I2 dash equation. So equation 1 minus 7 into I1 plus 6 into I2 dash. So I1 equals to I2 dash equals to 7 by 6 into I1. So this is equation number 4. So next from equation 2 write I2 equation. So by using this equation write I2. I2 equals to 3 into I1 minus 6 into I2 dash. So equation number 5. So next to substitute I2 dash and I2 in equation 3. So equation 3 becomes V2 equals to minus 2 into 3 I1 minus 6 into I2 dash plus 2 into 7 by 6 into I1. So this equation becomes V2 equals to 6 into I1 minus 14 into I1 plus 7 by 3 into I1, or V2 equals to minus 17 by 3 into I1. So next y12 formula, y12 equals to I1 by V2, I1 by V2 equals to minus 17 by 3 into I1. So y12 equals to minus 3 by 17 moles. This is y12 value. So next one y22. So y22 formula I2 by V2. So to find y22, express V2 function of I2. So V2 equals to, so current into resistance. So V2 second port voltage, it equals to second port current into, so second port resistance, or resistance across the second port terminals. So here R equivalent is the resistance across the second port terminals. The resistance across these terminals is R equivalent. So to find R equivalent, so we have to reduce the network from opposite side. So opposite last two elements 1 ohm and 6 ohm. These two elements connection parallel connection. So 1 ohm 6 ohms in parallel connection. So next this combination in series with 4 ohms. So plus 4 ohms. So next this total combination in parallel with 2 ohms. So parallel with 2 ohms. So first 1 ohm 6 ohms parallel connection. So R equivalent equals to 1 into 6 by 1 plus 6. Use formula R1 R2 by R1 plus R2 plus 4. So next this total combination in parallel with 2 ohms. So it equals to 6 by 7 plus 4 parallel to 2 ohms, or it equals to 34 by 7 parallel to 2 ohms. Again here parallel combination. So use R1 into R2 by R1 plus R2 formula. So finally R equivalent equals to 17 by 12 ohms. So V2 equals to IT into R equivalent equals to 17 by 12. Y22 formula I2 by V2. So I2 by V2 equals to I2 into 17 by 12. So finally Y22 equals to 12 by 17 moles. So the Y parameter matrix. So Y equals to first Y11 value, next Y12, next Y21, finally Y22. This is Y parameter matrix. So Y parameters are also called as admittance parameters and short circuit parameters.